This is an old Mikron TH-5104 thermal imaging camera. A friend gave this to me. It's a older thermal imaging camera. I'd say it's probably about 18 to 20 years old now. I think it's about 98, 96 or so. It's has compact flash memory in a PC card holder. It has NTSC video output capability. So this was probably a fairly expensive imager when it was new. But, well, you know, changing times and technology. Things are smaller, faster, better. So, how did this work? Well, it's really hard and really expensive to have a thermal imaging camera with lots of resolution. So what they did here was they have a single imaging device right here that only detects the signal in a very small spot. And to make this small spot cover a large screen, they use moving mirrors to jiggle back and forth and make that small spot cover the entire area to cover. So there are two mirrors here. You got one here that jiggles the image left and right, and then there's a second mirror here that jiggles the image up and down. And so with these two acting as an XY coordinate system, they move this so that this single point camera covers a large area. Also, if we look back here, you see this thing right here with the blades? That's a shutter, basically a camera shutter, so that when these mirrors are moving to the next spot, the camera is covered in black, so it's not seeing anything. So it uncovers, detects a spot, covers, and then the mirrors move just slightly to the next position. It uncovers and detects the spot, and in that manner it builds up the complete image. Also, this is an older technology where the thermal imaging device has to be cooled below ambient temperature, and that's how it compares the below temperature to the current temperature. So on the back here, this is a Peltier plate thermocouple cooling system with a heatsink and fan to cool that down. So when you first turn it on, it doesn't turn on instantly. It takes a little while for the system to cool down. So I will turn it on here. And as you can hear, it is humming. And specifically, it is the small mirror right here, this XY mirror, that is humming. The upper one, that would be the horizontal mirror. That would be the X-axis. The Y-axis mirror up here is not moving yet. And if we look at the display, it says wait. And that is because it is currently cooling down the imaging device. All right, it has now started rotating the shutter. So that's stage 2 of the startup process. The shutter is now spinning. And yep, this is definitely cooling down. And there we go, it started moving the vertical axis plate. And there we are, now the camera is operating, and I'm sitting in front of it, so it's detecting me. So there we are, the imaging camera is functioning properly, everything is ready to go. And there's no real lens over this thing. What it just has is a plastic dust cover, and thermal radiation just passes through that inside. That just keeps dust out, that keeps people from getting their little fingers in here and touching or damaging any of this, because these are all front surfaced mirrors. They're all high precision surfaces, and in which case I'm exposing it to dust by opening it up, but it's okay. It's an older device. I'm not really that worried about its operation. You know, we don't really care a whole great deal here. It is a fairly nice device. I mean, you know, for the amount of work that it is going through to create this image, it has some lines. The lines that you see in the camera are what I see on the LCD panel. That most likely is due to slight misalignments in the mirrors. The mirrors perhaps aren't moving their full range, or there's something that would need to be adjusted. But you know, it's a 18-year-old device. You know, mechanically things have probably moved around a little through the life of the thing, so I'm not going to be too worried about this. You know, there's probably a way to adjust the mirrors to improve the image so it doesn't have those streaks on it. But you know, it's not that big a deal. And it looks like down here, right here at the bottom, that looks like a focusing stepper that adjusts the distance of the camera in and out from the moving plates. So part of the reason for me opening this was that I just wanted to find out, is there any way to quiet this thing down so that it doesn't make as much noise? Because my friend that had this wanted to use this as a wilderness camera, but it's pretty hard to use this quietly with all the noise it makes. And unfortunately, it looks like there really isn't anything that can be done, because this stuff is oscillating at a high rate of speed. You know, this one right here is really moving, and it's on the end of a torsion bar right here. So here's that sensor. So this right here is what's making the most noise, but there's really nothing you can do about it. You know, you don't touch it, you feel it vibrate. So it is what it is, you know. And you can obviously go out and buy a new FLIR. Let's see, I think they call it FLIR 1, that plugs into a smartphone, and that thing's tiny, doesn't make any noise, and you can do imaging straight from your smartphone. But you know, it's technology. That's just the way technology is. You know, this is all large chips. You know, all typical of what you would expect for a mid-90s electronic device. So, you know, works okay. Well, thanks for watching.